This is practice A for section 8.2. We're going to find the measure of the indicated angle in the parallelogram. So again, they're telling you these are parallelograms. Remember what that means by definition. The left side and the right side are parallel. The top and the bottom are parallel. And that's what it would look like if they didn't already tell you it was a parallelogram. So it's not a parallelogram because it looks like it. It's a parallelogram because of the marks or because they tell you. Okay, so find the measure of angle C is what they're asking for. Remember, these angles that are adjacent or consecutive, they're supplementary. So this angle is going to be 61 degrees. Same thing now. This is a parallelogram. If you know this angle is its supplement. We want to find angle K in this one. These are supplementary. Same thing with these. Okay, so you do that the same way. 10 through 12, we need to find the value of each variable in this parallelogram. So again, these are all parallelograms. I don't have to put the marks on. I just wanted to show you that that's what those marks mean. We haven't discussed what happens with diagonals of a parallelogram yet. The diagonals bisect each other. So what that means is this piece and this piece are the same length. So if we knew this whole thing was 30, let's say, that would make each of these pieces 15 because they match. Likewise, let's say this whole thing's 24. That means that these two pieces are the same. That would be 12 and that would be 12. So you're just finding the value of the variable that makes this equal 15. If that's 15, that's 15. 8 plus 7 equals 15. So model that with an equation because eventually it's going to get tougher. Same thing going this way. Some number minus 8 is 12. Add 8 to both sides. Diagonals of a parallelogram bisect each other. So that's how that goes. Again, these will be the same and these will be the same. Now notice, parallelograms in general are slanted shapes. So one diagonal is going to be longer than the other. So don't make the mistake in thinking that these all match. Obviously they could, and we'll get to those situations down the road. But for right now, we're just dealing with ordinary parallelograms. Okay, so I guess we'll just do this one. If this guy is 12, this guy is 12. So 3 times something plus 6 gives you 12. We'll subtract 6 from both sides. Divide by 3. This guy's 27. This guy's 27. So 2y plus 9 is 27. We're going to subtract 9. Divide by 2. This guy's the same way. Those match and those match. So set up your equations, solve for your variables. Let's use this diagram. This is parallelogram MNOP. Notice how they're using 4 letters and they're naming that quadrilateral correctly. They're starting at any vertex they want and they're going around the shape. So let's figure out the things that we know. What is segment MN congruent to in this parallelogram? Segment MN would be congruent to segment PO. Explain. Well, the opposite sides are congruent. That's a theorem. That's the explanation. I'm not going to write it out, but you can. Number 14, segment MN is parallel to segment PO. Segment ON is congruent to segment MP. Opposite sides are congruent. That's your explanation. Angle MPO. Let's trace this with our finger or our pencil. MPO. That's this big angle down here. So if I was to redraw my parallelogram, we're talking about that angle right there. It's a little bit easier sometimes to see a parallelogram when you don't have the diagonals on it. What's that angle congruent to? Well, it's definitely congruent to this one. Just make sure you name it correctly. You can call it angle MNO. Okay, so on and so forth with these. You're matching up the parts that are congruent.